All right, guys, let's go ahead and start chapter 11. It starts off relatively slow, so we'll go ahead and do one assignment this week. It will be a due on Thursday, but I'll probably make it due later in the day than normal, so you've got plenty of time. I don't think this one will be all that difficult, though. The difficulty is going to be in me drawing the shapes because we're now going to go into three-dimensional images with the areas and volumes, surface areas, things like that, that we'll get with three-dimensional figures. So let me draw one here with my stylus. Hopefully, I can do a decent job of it. I'm going to draw what's called a prism. A prism is basically just a rectangle a lot of the time. Let me erase part of that. And actually, that one's a solid line. And so there you have the rectangular prism. You can see the dashed areas, which are the hidden edges. Now we've got to do a few definitions here. A face is the rectangular portion. So that's a face. An edge connects two of the vertices. And then the vertex point is basically where multiple edges connect. So this vertex here is where 1, 2, 3 different ones. And in three-dimensional shapes, a vertex or the vertices will always have three edges that intersect. So when you hear those terms, you will need to have a basic understanding of what that means. Typically, what will happen is they will label the vertices with letters, and then you'll be able to label the figure and all that kind of stuff. It can be a little bit of a challenge sometimes to see what shape is being indicated, but with a little bit of practice, you'll be able to do it. If you can't draw the image, you might turn your computer on its face and trace it from your book, your computerized book, or you can just practice it. Some of you are much better at drawing than I am. So let me delete this one here. Go ahead and erase this one. And we'll turn to the first little formula. It's not a hard one. I would go ahead and take notes. As you notice from this test, all your tests now are going to be open notes. So I would take some notes from both the book and from my little video lessons like this. Take them just the way we've been doing all year long. If you see a key definitional item in your book, then go ahead and write down the term face and then write down the book definition of it and kind of think about it. Put it in your notes just in case you need it for a test so you've got quick reference. Now, what we're going to do now is called Euler's formula. This is Euler's formula. It's a big old box in your book. So this is one of those starred items when we're going through notes. Basically, it says that the sum of the number of faces and vertices, so the sum of faces and vertices, is equal in a polyhedron to the number of edges plus 2. So in that last shape that I drew, I'll recopy it here. Here we've got our rectangular prism. Okay, well, let's count up the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm seeing 12 edges. I may have to count that again, but let's try faces and vertices. Faces, 1, 2, 3, 4 on the bottom, 5 and 6 in the back. So I'm seeing 6 faces. So we should get 8 vertex points. 1, 2, 3, 4, 5, 6, 7, and 8. So you can use that formula to quickly determine what type of a shape you might have. It's not going to be that big a deal in this chapter, but you will get some problems in this first section. All right, so that's Euler's formula. I think that one example is probably all that you're going to need. If you need to, please look at the book for an additional example or two. And then, guys, let me remind you, because I've been really pleased with my geometry classes, the number of students that are getting online for tutoring sessions. But I want that to continue even better. I still have some students that I have not seen once in tutoring, and some of those students struggled on this last test a little bit. So let me help out when you're struggling with a section in the book. All right. You can also use Euler's formula in 2 dimensions. If you'll listen to this while also looking at problem 3 in your book, it's a lot easier than me trying to draw it. That would take a bit of time. Okay. If you've got a net of a 3-dimensional image, and if you remember, a net are those shapes, it looks like they've taken something and cut all of the edges open and laid it out flat. It's almost like a puzzle of putting together 3-dimensional images. Well, you can see in the number of regions in this picture here, you've got 6 rectangles and then 2 hexagons top and bottom. This is a hexagonal prism. Prisms create rectangular faces. And there should be 6 faces around the side plus the bases, top and bottom. But the faces are created by the number of sides of the original shape, in this case, hexagon. So you'll notice on this that you have the number of regions is 8, which stands for faces. The reason there's 8 is there are 6 rectangles as faces and 2 hexagons as the bases on those. Now the vertices, you'd have to count up every single spot where 2 things hit, including from the hexagons, because remember the hexagons will fold in. And so if you go through there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 vertices. And then the edges would be 29. And so you've got faces of 8 plus 22 vertices. So 8 plus 22 on this side of Euler's formula has to be equal to our edges. And if you count up all of the edges, you just basically count the segments, guys. That's 29. And in this case, you've got the 1, since it's a 2-dimensional shape. It's a little bit different because you've got a 1 here instead of a 2. If you remember an original Euler's formula, it's 2 more than the number of edges. This is slightly different because it's a 2-dimensional shape. So this right here is the key difference. That 1 right there. If you're looking at a 2-dimensional net, you're going to have to change it up a little bit. Finally, it talks about cross sections. Again, I'm going to have to ask you to please listen to this instructional video while looking at the book. Just some of these things in geometry are too complex for me to draw quickly. All right, a cross section is basically taking a 3-dimensional image and taking a rectangular plane, almost like a sheet of paper that's razor thin and sharp, and cutting through the middle of it. So if you'll look at problem number 4 on page 690 in your book, what is the cross section formed by the plane and the solid at the right? Well, the cross section is the yellow sheet of paper looking thing. It's a rectangular plane, or it's a rectangle. Okay? So that cross section is a rectangle. And you'll notice it cuts through the cylinder and creates 2 half cylinders. Those cross sections are going to be used at times, and you're going to have to use your 3-dimensional senses to kind of see what shape is being formed. For some of you, if you're like me, this will be a little bit difficult. This was always the part of geometry that I struggled with. I don't turn 3-dimensional shapes in my mind very well and look at them on paper and understand them. it is one of those things that's a skill that can be learned. So, for example, look at number 5. It's even titled Visualization, problem 5 on page 691. Draw a cross section formed by a vertical plane intersecting the front and right faces of the cube. What shape is the cross section? Okay, so we're going to use a vertical plane intersecting the front and right faces of the cube. And you're going to cut through that cube. Okay, so you're going to visualize that plane as a paper, almost like slicing off that corner of the cube. It has to go through the front and the right face. Well, look at the parallel segments that are formed where the paper cuts through the shape. And then look in your book at the yellow highlighted image and see that they've got a triangular prism that has been cut through there. But the cross section itself is a rectangle. Okay? So you've got a cross section coming through there. You've got a triangular prism that is cut out of the cube. And then the cross section itself is a rectangle when you pull that triangular prism out. Remember what I said about a prism? The faces of a prism are always rectangles. And so when you pull that piece, that triangular prism out and look at the face, that face is going to be a rectangle. How many rectangular faces does a triangular prism have? Hopefully you've picked up on the fact that they each have 3. If it's a square or rectangular prism, you'll have 4 rectangular faces. If you have a pentagonal prism, 5 rectangular faces. But in this case, it's still a rectangle. All right, guys, I hope that helps you. Not too long, just a little bit of brief information, and add that to your book to figure out this first section. I'll put Math Excel online right now, and I'll make it due late Thursday, so you've got plenty of time. Good luck. Test grades, I've pretty much got them finished. If you want to look online, you can see how you did on your test. If you've got questions, feel free to shoot me an email or ask on a Zoom meeting if needed in tutoring. Take care, guys. Have a good week and a great weekend off.